Okay. So announcement. The first announcement is that the homework is due tonight. I have already um at 11:59 p.m. I have already created type for you to submit the course. So like if you finish, please just like submit right now. Or else you might forget. Um Second of all, we will not have a or like in this class you are supposed to do the midterm quiz, which is also part of the midterm, I think. And it is open now and will be closed, I believe 6:30 p.m., but I might be wrong. But that's what I think. That's what I remember. But so during the section, I will provide you 20 minutes to you can take it in another time. I mean, you have to take it today, but like you can take it and another time instead of the section right now. But I was told that I have to provide you 20 minutes time window to do the quiz. So during the section, I like presumably after this announcement, I will give you like 20 minutes to do the quiz. Like one thing good of doing the quiz right now is that if you have technical problems, I can like prove that you have technical problems and I might give you some like solution to solve this problem. If you do it by yourself, there's no guarantee that if you face any technical problems, there's a way to solve it. And and let me just mention like a few things about the page. So I think a lot of you has already been through web work already. So for the on the web work, so if you access web work, you first go to B course, and then on the side there is a bar called web work. You click that, and there is like a midterm true and false multiple choice tab, and that's for like 2 p.m. section. We are 2 p.m. section, and if you click in that, there will be like 13 problems, I think, because I also do this problem. Like a professor asked me to try it out to say like if there's any like technical issues, and I think it's pretty well designed because they are like for each type of problem there are like 3 to 4 like each of you will get different tests. For each type of problem there will be like 3-4 questions that are similar, but there are some like nuance between those type of questions, and there are like 13 questions, and they are like reordered, randomized. So in fact there's like almost infinite combinations to avoid cheating. And I would say it is not too hard, but it can be tricky. And it's actually pretty tricky. Some of the questions are pretty tricky. So if you want to like have more time to prepare about that, probably just like go through the definition more precisely. Some of the has like pretty tricky on the nuance of the definition, but like most of them should be like pretty straightforward. Like yeah, you should encounter some of the problems during the discussion and during lecture, like what she emphasized on. And yeah, I would say not hard but tricky. Yeah, and this is the window for the web work. And after you do like a lot of problems, at last there's 2 buttons. One says preview, one says grade test. So you always want to click the grade test thing. Don't click the preview. If you like click the preview, it will just like preview, but like it will not record your answer. And also like one thing I want to emphasize is that once you click in to the tab, the timer starts to time, like the time starts to drop. So you just if you so don't like just click now and you don't want to do the thing. Click it when you're ready and you are actually spending that 20 minutes to do the test, or else like you're just like wasting your time. And another thing I need to mention is that yeah, just like stick the 20 minutes in doing the test. Don't like just do 5 minutes and you think you want to like do it another time and leave. That the timer, I'm not sure, like the timer may be still like time, and in fact the timer should be like still like dropping. And also don't click return the web page. Just click on the page and do it, finish it. Because if you return it, your answer might not be recorded. So always make sure that you click the grade test before the timers end, so that all your answers will be recorded and submitted successfully. And like the previous quiz, I will give you like 2 minutes grace time. This time we are like strictly 20 minutes. You don't have like a single second for your quiz time. Yeah. So yeah. And as for the quiz, so there will be like no quiz of today, and there will be like a quiz on Thursday. So the quiz on Thursday will cover the material that we went through today. So we will cover the maximum likelihood. And the reason that we are having a quiz is because like, I mean, that's what Professor Stankovic told me, is that we're taking the highest 10 or 11 or whatever number quizzes instead of like dropping the lowest. So that means like the more quiz you take, the better the better result you will have, because we are taking the highest, not dropping the lowest. The more quiz you take, the higher chance that you have a higher quiz score you will have. So yeah, I just mentioned that like you guys can hear me correctly, right? So the quiz will be like materials. It will include the material, but not just limited to the material on Monday's lecture. What is the grading for transform like on the midterm quiz? So the total grade is like 41, or like there are 13 questions, and the total grade is for 41. I mean that's what I did. I mean that's what I think. But like I don't know how do they get the 41 points, because like I don't know, maybe like because in the 13 questions, 12 of them are the actual problem, and one of the problem are the honor code. So I mean, if I were to grade this problem, I would say that probably 3 points for each problem, and like if you as long as you answer the honor code, you get 5 points for free. Oh, the screen's frozen. I actually wrote a lot. Okay, I think it froze for like 5 minutes. So that's the thing I mentioned before. Like there's two buttons. You click the grade text instead of the preview, and okay, so like look at the in chat about the what are talking, like what are the gradients. So I'm also like not sure about that. So yeah, maybe you can chat each other. But that's all for the logistics. And like maybe like mentioning more questions in the next 1 minute. and I will leave you 20 minutes to do the midterm quiz. And I will see you, or I mean, in the meantime, you can like just leave the chat or come back and then come back. I will take the attendance after 20 minutes.
Oh, sorry. Guy. Hello.
Great. Yeah, so I think that's the end of 20 minutes. You guys should be able to like you guys should finish it. If you didn't finish it, that means like you start late. You can just like mute what I'm talking about, like, and then focus on your work. But for everyone else, I will assume that if you stay here and you can like hear what I'm talking about, you are actually finished with your quiz, and or you didn't do it at all. But like definitely be aware that if you didn't do that, you have to do it sometime today, like before afternoon, like before 6 or something like that. So you have the opportunity to finish it today. If you didn't do it today, then I cannot give you a guarantee that you will receive your score. So there's a great chance that you will receive a 0 for this transfer problem. So be aware of that, and also like remember the homework due tonight. Please submit it if you finish it already, because I haven't seen a lot of submission right now. Yeah, and in the meantime, like I just like input your midterm grade. I think like most of you are doing pretty good, and like almost everyone gets some improvement from midterm 1, and I'm also like very glad to say that. But if you are concerned, like so I know, like I also noticed that some of your decrease like are not performing as well as you are doing on midterm 1. So if you want to like talk with me on like why you are getting such a low score, or like if you are like unsatisfied with the score you get, and you want to like talk with me how you are gonna improve your midterm or your final score at the end, feel free to like send me an email, or like drop by during office hours. I was told that I will prioritize those who want to talk me about their midterm 2 than the questions from professor. But like the talking midterm 2 includes 2 parts. You can either like talk with me with specific problems, or like it actually includes 3 parts. You can either talk with me with specific solution for the correct answers, or you can like discuss with a regrade request, and you can also like talk with me with a specific advising on like why you are doing it wrong, and how should you do it, how should you think to make it correct, or perform better on the final. That's all the things you can talk with me during math hour, or like you can send me an email. We can arrange another time. Yes. So let me to mention something. Okay, I forgot what I want to mention, but yeah. Do you guys have any questions? Like in terms of midterm 2? Okay. So guys, this is no. So I will jump straight into the actual content of this discussion. So there's only like one lecture we went through before like this discussion. It's lecture 13, maximum likelihood method. So the maximum likelihood method is basically another perspective of thinking conditional probability. So maybe like an example is better than plain words. I will just like mention an easy example Professor Stankova mentioned in the lecture. So say if you have 2 dice, one of them has 5 blues and 1 red, and the other has 2 blues and 4 red. So the maximum likelihood of the first, or the likelihood itself, is defined to be like for example, the likelihood of given the die you roll is a blue, what is like the likelihood of the first die is defined to be, so that definition is defined to be the probability of given that it is the first die, what's the probability of it is blue. So we know that given it is, so say this is the first die, this is the second die, given this is the first die, the probability it is blue is 5/6. There's only 5 chance out of 6. And the likelihood of the second die, given the fact that we have the die shows the blue, is defined to be the probability of blue given the second die, which is 2/6. And we know that the likelihood of the first die is greater than the likelihood of the second die. So we can draw the conclusion that the maximum likelihood appears at to be the first die. So that's a simple example. But like remember the random variable itself can be very, like in this case it's just a simple Bernoulli trail. Like the random variable itself can be like Poisson, can be geometric, can be binomial. So in general, the way we think about likelihood is different from probability distribution, but in a sense they are the same. So for probability mass function or probability distribution, you are giving that like x is unknown, like you are finding the distribution. So like this is an unknown k, but you know the parameters, but don't know k, like don't know like specific case. That's why you are giving a probability distribution. So let's take binomial as an example. The example binomial is that if you have like the probability distribution is n choose k times p to the k times 1 minus p to the n minus k. So that's the probability distribution. And why do we have that probability distribution? Because so if you have a probability distribution, that means like you have already known n, but you don't know k yet, but like you might know k for a specific problem. But if you don't know a specific problem yet, you are just giving a probability distribution. But for now, for likelihood, it's like it's still the same thing, n choose k times, and also like here you know the probability p. That's also like a parameter input. But now like for likelihood, that's the same, still the same format as the probability mass function. But right now it's like you don't know p, but you know n itself, and you know k because you are giving a specific sample. So that's kind of like a difference between likelihood and probability mass function. So maybe I want to like re-mention the examples you mentioned in class, because like after me explaining like the difference between these two, you might have like a better understanding in another perspective of this problem. So the examples you mentioned is like you have 12 blue or red marbles in the box, and so second red marbles, and you pick 4 with replacement. Pick 4 with replacement, and the result is 3 red, 3 blue, and 1 red. So you want to find the maximum likelihood, and the way you are doing it is because we have a measurement. We have a measurement of 4. So the function LP, which is the likelihood based on a variable P, is defined to be because we know that this is binomial, it is like picking without with replacement. So we know that like n is equal to 4 in this case. And then we know that we treat like blue as a success, and we have like 3 success. And like there is a probability for each Bernoulli trail. Like there is a probability for success rate, which is the rate we find a blue trail, which in this case is the number of blue over 12. So that's the p, but we don't know it yet. We want to estimate. We want to like find the maximum likelihood. So like maybe like thinking from this perspective, this is the likelihood is much easier to understand. And moving forward, there are 2 ways to solving, or like there are at least 2 ways to solve problem likelihood with maximum likelihood. The first way is to count. So we know that because this proportion, this probability is discrete, is a binomial random variable, and we can either have 0 blue or 1 blue or 2 blue up to 12 blue marbles. So p can only be equal to 0 over 12, 1 over 12, up to 12 over 12. And then like we have like finite amount of value of functions, and we just plug in this function and get all the results. And then we compare this 12 results and find the maximum of LP. And the result is the maximum likelihood. So each of them are likelihood, and we find the maximum, which is the maximum likelihood. The other way of solving this problem is to to change the discrete to be a continuous function. But we know that this function is theoretically not a function because it is not continuous. I mean, in a sense, it's a function, but it's not a continuous function. But if we change it to a continuous function, that means like we instead of define p in only 13 values, the 13 values are 0 over 12 up to 12 over 12. We define p for any like probability on the range of 0 to 1. That means like the function itself has a value from any point 0 to 1. That means the function is a continuous function. And the advantage of having a continuous function is that it is easier for us to calculate the maximum. So for example, like during calculus, we learned the derivative method. So LP in this case is 4 to 3 times p to the third 1 minus p to the first. Yeah, because like k is equal to 3, you find 3 marbles. And the function itself can be simplified to be 4p square minus 4p to the fourth. And you can like take the first derivative of that, which is okay. The lecture permits to use theta instead of p. I'm always like making this nothing wrong. You make the first derivative 0. So what does the first derivative, like I'm just like reviewing the calculus concept. So given any function, the first derivative is 0. That means at a certain point, the tangent line to that point is like flat, it's horizontal. So it can be here or here or here or here or here for any function. And the first derivative equal to 0 means it is either a local minimum or a local maximum. So in this case, we like solve for p, and these p's are either local maximum or minimum or the endpoints. But like we don't really care about endpoints. And then we do a second derivative, and we find if second derivative is positive or negative. If second derivative is negative, that is concave down. So that means concave down means this, like the case, like it is concave down. Like that means like if the second derivative here at this point is concave down, that means it is a local maximum. So concave down infers local maximum. Like usually for the question we gave you, there's only like one local maximum, so you can just like treat that as a global maximum. But like in general, if you are facing a very complicated question which contains a lot of local maximum, so a lot of p satisfies these conditions, we need to find the max of all local maximum to find the global maximum. And the global maximum in this case is our maximum likelihood. So that's the second way. And the third way is to take a logarithm on the function. Take log, and like sometimes taking log can be like is my internet lagging? Yeah, the screen is frozen. Let me like restart the screen. Okay, so the third way is to using logarithm, and the way is we do that is by taking a natural log on the original function. Like theta, the notation theta is just the notation of probability I'm writing here. And the advantage of that is because if we take a derivative on this function, by chain rule, we'll first do a derivative on logarithm, which is f theta over 1, and then we take a derivative inside, which is f derivative theta. And if we set this to 0, that's the same thing as telling us f first derivative is 0, when f itself is not 0. And the advantage of doing that is it's like in some function which contains multiplications of variable in various forms, of variable in different forms, or it contains I will give you an example later, or it contains like e to the x, something like that. So for example, if you have a logarithm of if the original function has like e to the theta times I don't know, theta to the 10th. So if you take log of this function, because there's a property of log that if you take in something times something, that's just a log of something plus a log of something. And another advantage of natural logarithm is a base e. So taking this term is directly, we can calculate it to be theta. And this term is just 10 times log theta. So like we can simplify the function. So there isn't like too much difference between these methods. The only difference are like in some methods where it's easier to solve the function is to find the derivative algebraically. There isn't like too much this statistical difference for this method. Yeah, so I think I spent a little bit too much time on reviewing the materials, and I guess it's a good time for you to do problem one. And if you finish problem one, probably look at problem 4 first after finishing problem one. And please update with me your progress on this problem. And as my screen is frozen again. And it might be because my internet connection wasn't that stable. So I'm like, the screen keeps frozen. Or like before we do the thing, maybe we should do a poll right now. Like, are you guys still with me? Like, I feel like no answer saying anything. Yeah. Okay. Okay. So so yeah, let me launch the pool. Yeah, and you have like 2 to 3 minutes to do the pool. Okay, you have 30 minutes left, and there's still like 5 of you haven't voted yet. Wait, did I say 30 minutes? 30 seconds. Okay, the poll will be closed in 10 seconds. Okay, I'll close the poll right now. I mean, there's one student who hasn't voted. Probably he's already gone. End the poll. And I want to share the result with you. Can you guys see the result? Like, I'm actually pretty shocked because like where is it? There's so many students who answered true for the first problem. Like the answer for the first problem is false. Like that's precisely what I just mentioned before I launched the pool. Like precisely the minute, the 2 minutes before the pool, and I'm like talking about the first problem. The first problem says that suppose you use the maximum likelihood method and your friend use the log likelihood method to find the most likely value for the parameter data. Then you and your friend could end up with different this is false. Because like, and this is very important. Like, so many people are like confused with this concept. The okay, so the reason why we're doing all those approaches is like for some specific type of problem. Okay. So there are like specific type of problem that that is easier to use logarithm log likelihood method to do the problem. But essentially the problem itself like gives you the correct answer. Like you can use like counting them directly to solve the problem. It just like takes more time. You can use like the second way from like discrete to continuous and calculate the derivative and find the second derivative to find the maximum. This is efficient, but like for complicated functions, like what I just mentioned is the example here. It might be like hard to calculate the first derivative and the second derivative. And for logarithmic way of solving the problem, it can be easier for certain type of problem. Like usually those problems are related with theta to the 10th power or e to the theta's power, that like you can manipulate it easily using a logarithm. But like say like e to say like another just like random polynomial function, you take logarithm, it might be hard for you to calculate. And for like other form of calculation, it might be hard for you using logarithm. But like these are just algebraic methods for you to solve the derivative problem. But they will give you the same result. So I just want to be very clear with everyone that the first problem is false. You will get the same answer. And I hope everyone are good with the answer and are not confused. So the solution for first problem is false, and for second problem the solution is true. So why is it true? The question is, if there are only finitely possible values for a parameter, then you can find maximum likelihood estimate for by simply computing individual likelihood and choosing the value that yields the largest value. Yeah, that's exactly the first method we are talking about. Just like counting through all the possible values in the range, and then calculate the result. For the question you guys are asking, caveat. Okay, so you are the one who didn't do the poll. Yeah, I will send you a private message about your situation. And for others, yes, you will get points if you did one correct on the poll. Yeah. Yeah, and that's it. If you don't have like more questions, please work on problem 1 and problem 4. And like feel free to tell me your progress on problem 1 and problem 4. And if you finish problem 1 and 4, work on problem 5, because like 1, 2, 3 are essentially the same problem. yeah, 1, 2, 3 are essentially the same problem, but like 4 and 5 are different variables, especially 4 are different. So the order is you first do 1, and then do 4, and then do 5. These are the 3 most important problems in this discussion worksheet. Oh, and one thing I forgot to mention is that for the requery request, I think professor mentioned about like how do you do the requery request, but like if you lose some points in like if you can like go through problem 1, if you like problem 1 is kind of like controversial because like there are 3 of us who are grading problem 1, and maybe like 3 of us grading scheme are like different. Like we are getting the rubrics, but like the mercifulness of 3 of us may be like different. Some of us may give like some points even if you didn't do it very correctly, and some of us may be very strict on like if you didn't get a perfect score on the specific rubric, you will get nothing from that rubric. So I mean, I personally are pretty mercy to students. Like if I see some like good result, I give you a lot of points. But maybe not lots of points, but like some points at least. But other GSS might not do that. So like if you think you actually have some like meaningful results, but you're getting a pretty low score in problem 1, especially 1B, like feel free to do a requery request. Like if I were the person who review your requery request for problem 1B, and you might get like 1 point, like at least 1 point back, because like I'm not that strict on that grading. So, but like you need to have like something correct that is strictly being punished by the rubric. In that situation, I might give you some points back. Yeah, that's what I want to mention. But like we are not encouraged for you like to just randomly spam the requery request. Like you have to like really think that you should get more points back to ask for requery request. And also you need to give reasons for the requery request on the request, I think. That's what I was. Yeah, and also like my office hours on Thursday and Friday 5 to 6 p.m. But like even if you come to my office hour to discuss the requery request, it's not guaranteed that I will be the person who review your requery request. But we can definitely talk about your midterm. Okay, so maybe like now is a good time to go through the solution for problem 1. So for problem 1, we're told to clean 100 times and get 62 heads. The question asks, what's the maximum likelihood estimate for your probability P of getting heads for any given flip? So after reading like in the first sentence, we're tossing a coin 100 times and get 62 heads. We like immediately know that it is a binomial random variable. Like X is the binomial random variable. and we can like immediately write the function of likelihood in terms of probability. Because remember what I mentioned before, the likelihood function is something that we know n is 100. We told you 100 times. And we know k specifically because we are given that we get 62 heads. We know k, but we don't know the probability. So we can write the L distribution immediately. And that's like one of the important steps here. And the other step is algebraic manipulation to find the maximum. The way we do that is by using the discrete to continuous. I believe it is called closed interval method. The way we do that is we first take the derivative of this function, and we either way is to take the constant naught. And remember, by the rule of product, for derivative, we take the derivative of the first term, and we let the second term remain stay still, and we take the derivative of the second term, which is 38 times 1 minus p to the 37, and by chain rule, we need to do derivative on minus 1 minus p, which is -1. And then we take out the common terms. In this case, is 100 to 62, and p to the 61, and 1 minus p to the 37. And inside, it will be 62 times 1 minus p, minus, because there's a minus 1 here, minus 38p. So the answer is 100 to 62, p to the 61, 1 minus p to the 37 times 62 minus 100p. And we want the first derivative to be 0. So in order for the first derivative to be 0, p can be 0, which means this term is 0, 1, which means this term is 0. Okay, because the screen is frozen again. Yeah. And the third answer is 62 over 100, which is the third term equal to 0. But we know that for probability of p equals to 0 or 1, it doesn't help, because if you look back at the original L function, it's just 100 to 62. 100 to 62 times p to the 62, 1 minus p to the 38. If you plug in 0 or 1, it just gives you the L function equal to 0. It doesn't help. But if you plug in p equals to 62 over 100, that's the maximum we're getting here. And the maximum is equal to, in this case, is 100 to 62 times 62 over 100 to the 62's power times 38 over 100 to the 38th power. So that's the maximum probability. Yeah. And maybe I will just go through problem 4 directly. So for problem 4, the question that there's an earthquake with unknown earthquake follows a Poisson distribution with unknown parameter lambda, and we want to estimate the likelihood of that. So first, we are given that the random variable follows a Poisson distribution. So remember, this is no longer a binomial distribution, but remember the probability distribution for Poisson distribution is e to the lambda times e to negative lambda times lambda to the k divided by k factorial. And in this case, lambda is unknown, while k is known to be 10. So we can write the L function to be lambda to the 10th, because lambda is unknown, but k is known, times e to the negative lambda over 10 factorial. And here's why, here is like why we need to use the log likelihood method, because remember, like, this is something that we are very, it takes our time to do the first derivative and compute the second derivative. So instead, we can take the log of this function. So, so the log of this function, oh my God, is that me or like all of you that nothing shows here? Maybe because my connection wasn't that stable. I don't know why. So we can write it as, or maybe you can just look at the solution. I'm just like explaining every step in the solution. We can rewrite it as ln 1 over 10 factorial times lambda to the 10th e to the negative lambda. And one thing good about log is we can like split this term into the sum of 3 logs. And another thing good about log is that when there's a e to the something's power, we can directly calculate that to be negative lambda in this case. And when there's a log of lambda times to the 10th power, we can write it as 10 times log lambda. And we know that this is constant here. And then it's easier for us to calculate the derivative. And then it's easier for us to calculate the derivative. So the derivative of the constant is just 0. And if we take derivative on 10 lambda, on ln lambda, that's just lambda over 1. So lambda, so 10 over lambda. And take derivative on negative lambda is negative 1. So the result is just that 10 over lambda minus 1. And we want this to equal to 0. That means lambda itself is equal to 10. Yeah, and if we want to check if it is actually actual maximum, and the way we do that is by taking the second derivative. And if you take the second derivative on this function, that would be 10 over negative lambda squared. And if you plug in lambda equal to 10 in, that's a number less than 0. That means it is concave down. And the concave down means there is a local maximum. And since this is the only critical point in our function, so that must be a global maximum. So I'm sorry, like the screen was like frozen. It was always frozen. I will like look into that, why that happens continuously. Maybe it's because my internet is lagging, or maybe my computer is outdated. But I will like definitely figure it out. So the other case, or maybe Zoom is broken. So the other case, like for other problems, 2 and 3 are the same problem as problem 1. And if you have time, maybe work on problem 5. Problem 5 is a geometric random variable, and we're using like geometric random variable to manipulate the maximum likelihood estimation. And I believe there are some questions about regret request. Yeah, I am also pretty sure that Professor Stankova don't like the regular request, you can't like submit regular request unless one of the GSI like unless you go through the problem with one of the GSI. So I guess that's the rule. But like you guys can like come to me and discuss the question. Yeah. So yeah, I guess that's it. That's it for today's discussion. And I will stay here for 1 extra minute for answering any question you might have. Otherwise, you are free to leave.
Wait, Sia,
Huh?
can
Yes.
I ask a question?
Okay.
On number 5, the solutions, I can't tell just by how it's written if they take the second derivative or not. Can you confirm that they do to find if it's maximum?
So the thing is that we're finding the maximum of that function, and if there's only one critical point, that means like it is either a maximum or a minimum. Since like I guess the solution just gave the step of checking its maximum here. So in fact, what you need to do is to do a second derivative and plug in that value of that critical point. See
Yeah,
if it is counting down.
That's what I did, but the second derivative I don't think is what's written there. That looks like the function to me.
Yes. So it is
But
not written there.
it is
You can do it, but yeah, it's just like the solution skips this step, then plug it in directly.
Okay, thank you.
Yeah. Yeah. Adita.